whatever data is on. I would suggest that you do this exercise on your VM. So if you see your VM, this is your VM. Not now, see it, because you cannot copy paste the data from your local system to this machine. Okay. Are you able to understand what I'm saying? You will not be able to copy the data set from local machine to the virtual machine. So you will use internet here. Just let me check if internet is there.
Yes, ma'am, it is there. I checked.
Okay. Then you will do all this on this. This is a virtual computer that you're using on IBM's network. So you will use the Internet Explorer here to go to the UCI machine learning repository, and then you'll be able to download the data set. Okay, fine. So now I will tell you. So we'll create a team and we'll work on different use cases. So in this way, what will happen is that we will actually learn from 5 data sets, because people around you are also working and they will also share the experiences, what they did, what went wrong, and what went right. Okay. So that would be better. Okay. Also, we'll go back to the presentation. Yeah. So there is more of marketing stuff. I'll directly go. Okay. So within SPS, I think SPS statistics is something which should use. SPS is not one product, it's a portfolio of products. So we have different tools within IBM SPSS. So we have tools for collecting the data, doing the data entry, then we have tools for cleaning the data, then we have tools for analyzing it, and then we have tools for machine learning. Okay, so let us understand what is the life cycle of a data science or a machine learning project. So this could be a question. This methodology is called CRISP-DM. It's cross-industry standard practice for data mining. That's the full form. You will get it in the module, but I'm telling it here also. It's called cross-industry standard process for data mining. Okay. So this is the standard methodology that we use while we do any project with any company. So you understand that IBM is a consulting firm. So we do product consulting plus we do solution consulting. So when I say product consulting, IBM creates software. So for machine learning, SPSS model is a product. So if we go to a customer, we have their data set, we also provide them the product, so product consulting, and also we provide them the solution consulting in case how we use the product to solve the data science and machine learning problem. Okay, so this is a standard approach where we meet the customer. The first step is the business understanding. So when I say business understanding, it is very important for me to understand the business, to check whether what customer is asking me for is actually a viable solution. Okay, so what he's asking me should have a dollar value. I mean to say that we just don't do projects because we should do it. No, we do the projects because it will give you back a dollar value. It will give you some money, and then IBM takes a cut out of that money, right? So that's how it works. So we have to do a solution so that we can save some money, and then we can also get our payment from it, right? So, so the first part is the business understanding, to understand the kind of business they are dealing with, and then second is the data understanding. So once I understand the business, how they're operating, what are the things they're doing, I need to see what kind of data they're collecting with regard to their business. Okay, so there is no whiteboard, but I'll try to use a paint. That's the best combination I got. Okay, so let's say that I'm working for ports. Okay, so I work for a company called Adani Ports. So they are the largest private port, and they handle around 55% of cargo that comes to India, comes and goes to India. Okay, so in a port, what happens is that there is a gate. Okay, let's say that this is a gate. Sorry, this is the best possible option that I could get. So this is the gate. There is a truck that comes, and there's a container loaded on top of it. So what they do is that they transport goods and cargo within a container, and they ship it. They export it using ships, and they import it using those ships again. So there's a truck that comes from, let's say, there's a good from Delhi that comes to Adani Port in a truck, and this truck comes to the gate of the port, and once it comes here, it goes to yard. So a yard is a place, is a square box. So yard is a place where they will just store it for some time so that they can easily pick it up when the ship arrives. So the yard is divided into blocks. Okay. Let's say that this is a small description of yard. Let's say this is 1, 2, 3, 4, 5, A, B, and C. So this is a yard. So this container comes, okay, and they keep it here. Let's say 2B. This is the place where they keep the container. Okay, once they keep it here, later then there's a ship that arrives. Okay, so there's a ship that arrives. Let's see, ship. Okay, is that right? But I can't help it. Okay, so there's a ship. So they have to load this container to the ship. Okay, and within the ship also you have segments where to keep the container. Okay, so within yard also they have separate spaces for containers which carry frozen materials, containers which carry different types of sand, or different products have different kind of requirements for the container. So they have some demarcations here. So this map, a high level map that you see, is the business understanding part. And then when I go here, I ask them, okay, if this is your business that is getting the container into the port, going to the yard, and then loading onto the ship. If this is the business, what are the points at which you're capturing the data? Okay, so let's say that when the container comes at gate, here they will capture some data. Okay, here they will capture the time at which it arrived, what kind of container is it, or what is the number of the truck, where is it coming from, what is it carrying, when is it to be loaded. So these are the things that they will capture here. Then they will capture some data here about when did the container arrive, when is it to be shipped, where should it be located. Okay. Then they capture some data here. What time it was loaded onto the ship. So this container, when was it loaded onto the ship? So these kind of information they will capture at each point of time. Okay. So that is why you see here there is a two-way arrow. So here you have a two-way arrow which says business understanding and data understanding. So we need to understand, we need to have an overlap of the business process with the data map. Then only we will be able to understand, okay, what is happening. This is the process map, and these are the data points that we have. Okay. So why is this important? Because what we are trying to do in a predictive model, we are trying to create a hypothetical model. Okay, we are trying to replicate this process of bringing the container to the yard, to the ship. this process is going into a we're trying to do this in a mathematical way. We are trying to put this process into a mathematical equation. So we need to know what are the assumptions that are going at the back end. So we need to make certain assumptions, then only we can produce a predictive model. Okay. Any questions? Is it too difficult or am I going too fast?
Ma'am, what kind of hypothetical model that you are going to create? What is exactly?
So my meaning was that this process, business understanding, is going to be in a predictive model. So for this, we need to understand business so that we know where something is missing out. So let's take another example. Okay. Okay. So, there's I work with someone called Tata Steel. Okay. So, what steel plants do is that they procure some iron. Okay. So, they have some iron. They put it into a blast furnace. Okay. Let's say this is the blast furnace. They heat it up. Okay. And then they pass it into casted iron. So they have something called this, and they pass the molten steel through this, and they cast it into blocks. Okay, let's say they create blocks, some rectangular steel blocks. Okay, so this is what they're doing. So in this process, they tell me that they add the iron over here, plus they add some things extra. So let's say they add silicon. Okay, silicon they will add here so that whatever excess oxygen is there, the bubbles, the oxygen bubbles, they get evaporated and the steel comes out little smoother and solid. Okay, so this is the understanding. So if I tell them, please give me a measurement of how much silicon did you add? So they have nothing to say because there is some person who's standing near the blast furnace and just throwing it with hand. So let's say that there's a person here. Obviously, he cannot stand somewhere like this, but somewhere far, and he's just having it in a plate and he's just throwing it here, like sprinkling here. Okay, so if this is something, adding silicon to blast furnace with steel, okay, to evaporate oxygen. This process actually makes a difference and should go into my model if I want to predict the quality of steel. So let's say that I want to predict the quality of steel produced. Okay, so if I have to predict the quality of steel, then I should have a data point which actually captures how much silicon is getting added. Okay, if I don't have this data captured, then it might happen that whatever prediction I make here will have higher error rate. Got it? So for this process, we need to understand what is the business and what is the data that we have. Okay, so anything that is missing out will actually impact our predictive model. That is, we are trying to put it in a mathematical equation. That mathematical equation will be impacted because of less amount of information. Okay, is it clear?
Yes, ma'am. Yes, ma'am.
Yes. So we have to know what data points are available, how the process is getting impacted by different variables. Then only, so sometimes you would have seen those people who would have built models, predictive models, you would have seen that sometimes you will get a very, very bad performance of the model. You'll get a very bad accuracy. No matter what you do, you clean the data or you do anything, it's not improving. So it's not because the data is wrong or you have not done enough to create a better model. Sometimes the reason is there is not enough information to replicate that process into a predictive model. Okay, so we need to add more information to make that model better. The better the information, input information, the better the amount of input information, the better the model. So the lack of information also affects the model most of the time. Okay. So if this kind of problem arises, then you have to state that in your assumption that okay, this is something which I have assumed. So I have assumed that every time whatever silicon you are adding is of equal proportion. Okay, so you have to state the assumptions when you are building a predictive model. That is very important. Okay. Any questions? Either you're understanding everything or
no, we have understood.
okay, fine. So once we have the business understanding, we have the data understanding, and by these two steps, we will get to know what is our problem statement. So if you see, I gave you two examples. One is ports, one is steel plant. So by the time I do this business understanding and data understanding, I get to know what is my problem statement. So here, my problem statement was predicting the quality of the steel. Okay, predicting the quality of the steel. And here we could have, stated a problem like how efficient the yard is. So some part of the problem statement also comes from the customer. When they say that my port is inefficient, help me do something. Or my port is, I'm going to expand my container handling by 2025. I need to be more efficient, help me. So in those cases, we will have to analyze the most inefficient part and how can we increase the visibility in that part. So let's say that in the yard, the most inefficient part generally is the yard, because they bring and store it here, and it takes time to figure out where the container is and then load it onto the ship. Okay, so they should manage the yard very, very efficiently. So how can we do that? By we'll come to that. How we can do that. So once we do the business understanding and the data understanding, we know our problem statement. Okay, so problem statement could be predicting whether a person is going to default on the loan or not, or what is the quality of steel that is going to come out, or whether a customer is going to subscribe to my product or not. So depending on the kind of data set you're dealing, you come to a problem statement. So the problem statement in this scenario would be to build a predictive model. Okay. So how do we now proceed and build a predictive model? The first step is the data preparation. So I assume that the data has been made available to you by the customer. Okay. So data preparation, as the word suggests, preparing your data for the predictive model, preparing your data for the machine learning model, whatever we are dealing with. Okay. So what all things do we do in data preparation? So data preparation, sometimes people call it cleaning the data, data wrangling, data, a lot of terms are there. You can use anything, but the first term that came was data preparation. Okay. So within data preparation, we look at the quality of the data, how good my data is. Okay, how good my data is. Are there any missing values? So what all things do we check here? I'll just write it in maybe in Excel. Okay. Okay, so this is data preparation. What all things do we do here? The first thing that we do is the missing values. Why missing values? So if you have missing values, why is it, what will be the impact, or what should we do? Okay, let's try to understand what is the impact if we have missing values. Can we just use the data as it is?
No, accuracy we cannot get properly. So we had to remove missing values or correct missing values.
Yes, so accuracy may or may not suffer, but yes, there is loss of information. So if we have missing values, that means we have loss of information. Most of the times, when I was in college, I removed them, but not always in real world data you'll find an opportunity to remove them. So the best way is to estimate it. So what do? We can estimate the missing values. Estimate in the sense replace it by a different value. So these value can come in different ways. So we can either say we can do it by a constant, okay, constant or mean or median or mode. So we can replace it by a constant value. It could be anything, mean, median, mode. Is my text visible to you, or should I make it?
Yeah, visible, ma'am. It's visible.
Okay. So we can replace it by a constant. Okay. So what happens if we try doing this? So let's say that if I have 5% of the values which are missing, I can very well go ahead and do it, do the step. Okay. But what if I keep on estimating my values with mean, median, mode? What will happen? I mean, if I impute my values, let's say I have 15 to 20% missing values, and I impute them by mean, median, mode. What will happen?
Maybe those missing values we can cover it, and of course we may proceed with analytics. Analytics may be close to what actual things are there. So
Yes, but
we can.
there is a problem with this approach of estimating missing values by mean, median, mode. Why? What is the problem? That's what I'm asking.
Madam, it will reduce the errors, and that will be helpful to continue the analysis in SPS.
No, did you understand me? Let me put it in a better way. That if I have, let's say that I have a variable called age, and I have values 24, 25, 18. And then I have missing values here, and then somewhere here, and then I have values here, 25, 25, and then I have missing values. So what will happen if I continue replacing my values by mean, median, mode?
The entire distribution will not be affected.
Yes. You are almost there. Do you want to take another try and improve your answer? Okay, yeah, so almost you're there. So see what happens is that let's say your data distribution was, so all of us understand normal distribution, right? We'll take this.
Yes,
Okay.
ma'am.
So if my data distribution is like this, and we continue replacing my values by mean, median, mode, my data distribution will change. Okay, all these values will start converging towards mean. Okay, right? So this is, let's say that this is mean, and I am replacing my values continuously by mean. Let's say more than 15 to 20% of the values. My distribution actually changes to this, something like this. Sorry, it's very difficult to draw here. Okay, so my distribution is actually changing. And you remember the assumption that we had, that the distribution, historical data should be representative of future. So if my distribution itself is changing, all my model, all my assumptions will go for a toss, right? Is it okay to understand?
Yes, ma'am.
Yes. So this is the problem with this approach. So what is so if you have 5% values, it might work, okay? But the better approach is to the better approach is to, let's say, to use a predictive model. So how can we use a predictive model? We can so let's say that we have segregated a data set. I have 1,000, let's say 100 points, and I separated it into, let's say 20 are missing values and 80 are non-missing. Okay. So we use the non-missing. This is non-missing. Okay. So we use the non-missing to predict the missing. So this will not create a bias. This should not create a bias in the data set. Okay. This is one way. So we can use a predictive model. Another way is to use a linear trend, okay, or extrapolation. So homework, what is the difference between a trend and an extrapolation? Okay. So we can use a linear trend or extrapolation. So there's a trend function here. You can use trend. It uses a linear model, and then you can use these values. So it will create a trend. So what do we mean by a trend? A trend means you're trying to estimate a line y equal to mx plus c. Okay, it's very difficult. I should not write it here. Y equal to mx plus c. So how do we use extrapolation is something that you have to figure out. That's your homework. Okay. So once we have, let's say that we have a trend available and we have a missing value somewhere here, we can use the trend to predict it. Okay. So we can use the trend to predict it. Then another way is okay, let's say that another way is to use a distribution. So I can use something called normal distribution of x plus ei. So what do I mean here? So rand function, right? Equal to rand function. It creates random values between, let's say that I want to create random values between 25 to 35. 25 to 35. So this function will actually give 25 to 35. Okay. So another way is that I replace the values by normal distribution of x plus ei. So I'm adding an error term so that it does not impact my this distribution. So it doesn't make it biased. So I'm replacing it by a random normal of x. X is whatever variable we are looking at. Let's say that if we are trying to predict age, then x becomes age. Okay. Then we can have a random normal distribution of age with an error term. So this is something which I'll show you how we can do it. All these things we can do in SPSS modeler. I'm just telling you the theoretical part here first. Okay. So this is for missing values. Second is what we do is
Extreme values.
Yes, I am hearing only one or two people speak. What has happened to other people? I think we have 17 participants.
They are listening. Maybe very tough.
Okay, they're listening. Next time,
Chat.
sorry.
Some of them are typing the arrows also.
Okay, you can unmute yourself. It's okay. It's difficult for me to keep track of
Okay.
the same time. You can just unmute yourself. Otherwise, it will be only one-way session. Okay, outliers, extreme values. So why extreme? I mean, why do you want to? I mean, why extreme values are important?
They don't contribute anything to prediction, I believe.
Not always, sir. I will give you examples. So if you see they don't contribute to prediction, let's say that I have a financial fraud data, okay, financial transactions data, or let's say your credit card swipe data, and I see that, let's say this is the credit card swipe data, okay. So in a month, there is a group of people who spend only, let's say 25 to 55K in a month, but there is one transaction that happened for 2 lakhs. Okay, so this value is extreme, yes, but this value is also very important because it is pointing to something. I mean, some financial fraud that would have happened. Maybe this person's credit card would have got stolen. Actually, this is a financial fraud, and this could be linked to any kind of data set. You can take stock market,
Correct.
stock prices, or anything. Okay, so this kind of data might or might not be helpful to you. Sometimes, like in case of credit cards, it is helpful, but in other cases, it might not be valuable to you at all. So, what do we do with this? We can either, yeah.
The extreme values will be helpful to prepare for the worst, right?
I didn't get. Can you repeat it?
No, extreme values useful in the organization can prepare for the worst. So
First, yeah, that's what I'm saying. That in some cases, depending on the use case or depending on the kind of problem we are dealing with, it might or might not be useful. So it depends what kind of data we are dealing. If it is credit card swipe, then this is a financial fraud. If it is something else, let's say you're talking about equipment failure. Let's say that this equipment operates within this frequency range and suddenly there's a spike in the frequency.
Yes.
Yes, it could be a failure in the equipment, or there's something that is wrong. Okay. So depending on the use case that we are dealing with, yes, it might or might not be important. So what will happen if we keep the value as it is? I mean,
Estimation negative output. No problem. Can you use the stochastic process here?
sorry, can you repeat the question?
Can we use the stochastic process?
Stochastic process for what?
Determining the highest values.
No, I'm not asking how to determine those values. I'm asking if we keep the outlier as it is, what problems it will cause from the standpoint of distribution.
May affect the mean of the average.
Yes, it will affect
It will affect the mean.
yeah, mean and standard deviation also. Okay, so it will impact the standard deviation or variance and the mean as well. So what will happen is that so if we have a distorted mean and variance, our distribution will change. So let's see that the population actually follows this kind of a distribution, but because of the outlier, it is actually becoming something like this. Okay. So because of one value, we can't afford to change the distribution of majority of the population. Because if this happens, it will actually not be good for other people who form the majority of the distribution. Okay. So what we need to do is that for this, we need to convert. So how do we detect it? Okay, how to detect it? How to detect it? We use scatter plots. Okay, we will do it one by one in SPSS. Okay, B is what aberration will it cause? Changes normal distribution or majority of the population. C is how can we detect it? How to deal with it? So how do we deal with it? First point, we can simply remove it if it doesn't have any significance. Okay. If it has a significance, like in the financial plot data, then what do? We have to keep it, but we'll have to bin it. Binning. Binning is bucketing. That means you convert. So let's say that we have a variable called age. Okay. And we have values 25, 35, 45, and then we have 89. So what we do is that we bin the variable, that is we create something called age bin, okay, and say the person if he falls between age 25 to 35, 35 to 45. So we create intervals, okay. So we convert a continuous variable into a categorical variable. So we understand continuous, discrete variable. All of us understand, right?
Yes, ma'am.
Continuous variable, discrete variable. Okay. If anyone doesn't understand, please let me know. Continuous is anything like this, which can take values on any integer value or any real number. Categorical can also be divided into two, nominal and ordinal. Nominal variable is something like, let's say, what do you call it? Low default versus no default. Okay, and ordinal would be high, low, medium, agree, disagree, agree, strongly agree, do not agree. So these are the ordinal which can be ranked. If you do not, if you want me to explain, I will do a 2-minute explanation on this. So you can just.
Nivedita, I think you can just run us through it.
Okay, fine. So we have something called continuous variables. Okay. Continuous variables will be anything like age, okay, which can take values in any integer or real values from -infinity to infinity. Okay, so we call those continuous variables. Then we have discrete. From discrete, we understand that we have Was so we have
to launch the day.
okay. Okay. Fine.
You have sent it to Veena Krishna.
It will reach you. I think there are 3-4 data sets, so it might take a little time.
So we're going to be working with that now, right?
Yeah. Okay, otherwise, what we can do is, I'll just
I got it. I'm just forwarding. Nivedita, I think all of us have got the email.
So you can just open it on your VM machine. You can just go to. I'm not sharing my. So you will have. I see that you won't be.
Yes.
Okay. Um,
On-screen keyboard.
Then we have a two IBM. I'm taking over ball because you can feel your green ball here and then work on it. one import. Import is also used from an IBM tool. Model here. Excel, obviously, we will be using mostly Excel and WAR file. Excel for XLS files and WAR file for CSV files. Okay, and so on. JSON for Java, useful for equation data, and so on. So let's start with Excel. Then we have something called records. Record. So you understand what is record and what is field, right? So if you see my Excel sheet, what you see here, this one, customer churn, field, and record is yes, no, yes. So it's just same as observation and variable. So every observation for each variable. Okay. So whenever you want to do record operation, so these are the different operations that we have. Okay, select all of this. All of this. Logs again. If so we come to the then we have another tab for apps. We'll cover one by one. Then modeling, we have different models. Okay. We'll come to the details of how we create models. We're still at the then output, how we would take it out and export. Fine. So since for some of it's not working, I will show you the okay. So you go to file. Okay. Please follow with me. You go to file. Everyone with me can tell me yes, and then I'll go ahead. Open screen.
File.
Open street. Then you go to stack. Okay, I'll do it. Okay, you see a diamond icon here?
Demos.
Entries.
Okay, ma'am.
Things, if you just let's try to go to the last one, telco is before we understand it, just open and I am telling you the shortcut. Okay, sure, and then say open. So actually, SPS system modeler. I'm just going to it's called telco.ac. For now, just don't think anything. I'll tell you what is happening. You want the type the second node. Okay, type node, go to export, and click on double. You click on that, and this Excel. Click on Excel, type.
We are not getting, that's why.
Are you not able to see?
Simultaneously,
So it's see, see go to export here,
yes, ma'am. Okay.
I'll write customer, okay, and I will write the folder. If you click on this, see it will do just like this one.